1 diaphragm per mankind.
Humanity has always been drawn to the night sky. We draw pictures in the stars, track the planets, see signs and portents and celestial objects. But so much of the universe is beyond our reach. Vast distances separate us from the sights that might answer some of our biggest questions. How do galaxies form? How do stars and planets come to be? Do distant planets have the conditions necessary for life? To construct and test our theories, we need to see what's happening. So we build tools to extend our vision. They get bigger, more powerful, more advanced. As time goes on, science stops relying on the light we can only see with our eyes. When you look at the world, you are seeing something we call visible light. But visible light is really only a certain form of radiation. Our universe is full of many different types of radiation. It surrounds us. Our bodies evolved to detect visible light with our eyes. But they also evolved to detect another kind of radiation called infrared light. Our bodies feel infrared light as heat. This infrared radiation was discovered by the astronomer Frederick William Herschel. Herschel knew that a prism could be used to break the white light into colors. He wanted to know whether the colors had different temperatures. They did. But then Herschel measured the empty space just beyond the red light. Though no sunlight was visible, it was hot. Herschel had just discovered invisible infrared radiation. Humanity now knew that there were forms of radiation that could not be seen, could be anywhere around us. How many were there? What they were up to? What they were hiding? Obviously, we had to find out. A type of energy that travels through the universe in the form of waves is called electromagnetic radiation. The entire range of it, from high-energy gamma rays to low-energy radio waves, is called the electromagnetic spectrum. Although our eyes can see only visible light, we can build tools like IR detecting cameras to see other forms of radiation. These tools are man-made eyes that can view invisible radiation for us and transform it into pictures. Objects can emit all kinds of radiation. Observing the entirety of that radiation gives us a true picture of an object. When we turn these tools on space, they open up the entire cosmos to us and its full glory. When we look at the night sky, we see stars and planets, galaxies and nebulae in the form of visible light. But if we could see in infrared light, the sky would appear very different. For one thing, infrared light's long wavelengths penetrate clouds of gas and dust. The shorter wavelengths of visible light are stopped and scattered as they fight through the collection of particles. So by detecting infrared light, we can see through clouds of gas and dust to warm objects inside, like just forming stars. Objects that don't glow with any visible light of their own, like planets, are still often warm enough to radiate infrared light, perhaps allowing us to glimpse them. And by observing how infrared light from a planet's star passes through its atmosphere, we acquire clues about the planet's composition. The dust left by the distant planets as they form will glow in infrared, helping us to show how planets are born. So infrared helps us to see objects like these in our own galactic backyard. But it can also help us to observe the first objects that were formed in the universe after the Big Bang. Imagine you gave a letter to the post office in a galaxy billions of light years away and addressed it to Earth. It would travel an incredibly long time when it finally arrived at its destination. The person who opens it would be getting news from billions of years earlier. The light from the first stars to shine is something like that. It left the stars ages ago and it's still out there in space, traveling the vast distances between galaxies. If we could see it, we could see those galaxies as they were in the early universe. Essentially, we will be seeing back in time. But we haven't been able to see it. Why? Because the universe is expanding. As light travels across space, it is stretched like a taffy by expansion. The first stars gave off mostly visible and ultraviolet light, but the stretching changes those waves into infrared light. This is called redshifting. The only way to see that light as it arrives in our region of universe is to look for that faint infrared glow. By capturing it, we will be able to create images of the first galaxies to form in the universe. By witnessing the birth of first stars and galaxies, we deepen our knowledge how the universe as we know it came to be. How did we get from those first blazing stars to the islands of billions of stars we see today? What will we learn about how galaxies grow and evolve? How did the chaos of the early universe transform into the order and structure? NASA is currently building the James Webb Space Telescope. With its huge infrared capturing mirror and distant orbit far beyond the moon, Webb will allow us to view the cosmos as we have never seen it before. Webb will search for signs of water vapor on planets around other stars. It will take pictures of the universe's infancy. Webb will reveal the hidden stars and solar systems forming within cocoons of dust. The answers to some of the universe's biggest mysteries and more questions we haven't thought to ask are waiting out there for us in the form of infrared radiation. All we have to do is look.
So now we know what is infrared and how was it discovered. So simply, any form of matter that we can think of having a temperature, no matter how hot or cold, gives off thermal energy. A chair, a book, food, me. Everything around us. We know even the earth itself radiates thermal energy. Thermal energy which forms the primary source of what we call infrared radiation. Infrared being the section of electromagnetic spectrum that is just beyond the visible light in terms of wavelength size. Infrared radiation is invisible to human eyes, but technology allows us to detect and image matter in this very important part of spectrum. NASA, NOAA and other agencies use thermal infrared to study Earth's system in a way beyond what we could ever see. Through infrared data, we can study ocean and ice changes, map deforestation and forest fires, and monitor soil moisture and detect diseased vegetation. In fact, nearly every time we look at a weather report from a heat wave to a hurricane, we are using thermal infrared imagery. Satellites detect infrared energy in a way that let us study the Earth's weather pattern. It's as if the whole planet becomes visible to us at any time of day. Let us look at more uses of infrared radiation or IR radiation, which is emitted from all objects having thermal energy. With the amount that gets emitted depending on the object temperature. So, the hotter the object, the more infrared radiation it will emit. One use of this is in infrared cameras that help us to see in the dark, and in particular, to help us spot living organisms. By using special camera that can detect infrared radiation, we can see which areas are hot, which hours cold by measuring how much infrared radiation they emit. And so animals which are fairly warm will appear quite bright because they emit a lot of infrared radiation. Whereas their surroundings which are much cooler will appear darker because they don't emit as much as radiation. Another use in the cooking by heating metal to a very high temperature like in ovens and grills. We can make the metal emit lot of infrared radiation, which can then heat up food by transferring the heat energy, causing it to cook. Unlike in microwaves, though infrared radiation doesn't penetrate the surface of the food, which is why bread toast in a toaster rather than just getting generally warmer like it would in a microwave. We also make use of infrared radiation whenever we use electric heaters. These devices use electrical energy to heat up the metal of the heater. And then because it's so hot, it emits infrared radiation to the surroundings, which is able to heat up our rooms. So this has been Lidiya Sara
And Alwyn Sanjeev.
We hope you have understood the topic well. So this is our project on infrared. Thank you.